Hello, my dear students. Myself S. Devi, Assistant Professor, Department of Artificial Intelligence and Data Science, Rogini College of Engineering and Technology. I am going to teach the subject Operating System and Cloud Basics. We are going to discuss about inodes in operating system file system. First, we will see the definition of inode. The inode is a data structure. Inode is nothing but index node. It is a data structure used in Unix file system to store all information about the file except its file name, which is kept in a directory. It holds metadata. Metadata is nothing about data about the data. That is, it contains the information about the files and the directories. It acts as a file's identity card but does not store file name or actual content. It only stores the detail about the file. Each file has a unique inode number within the file system. What are the information that are present in the inodes are the file size, the file type, the permission, the owner and the group, timestamp, link count, pointer to the data block. File size is nothing but the size of the file. It is specified in byte. The file type is nothing but whether file is a regular type, directory, symbolic link, etc. Permission is whether the file is have any privileges like read, write, executed permission for owner, group and others. Owner and group. Owner and group. Owner is the owner who has the user ID and associated group which has the group ID. The timestamps, that is the creation and modification and access timestamp. The date and time of the last modification of the file data contains the information about the date and the time of last access of the file data and also the date and time of last change of the inodes. Next one is link count. The number of hard links pointing to the file, pointers to the data block, address of the file, data blocks on the disk. Next, we will see about the structure of the inode. The structure of the inode, it is nothing but an array. The address array inside the inode contains a pointer that can directly or indirectly points to the file data on the disk. Each file system maintains an inode table. When a file is created, it contains three information. An user inode is allocated. Its number is stored in the directory entry along the file name. The file name are stored separately in the directory and points to the inode number. The file name changes do not affect the inode. The inode number remains the same. A file system has a fixed number of inodes. If all inodes are used, no new files can be created even if there is free space. So this is the structure of inode, and next one is the detailed structure of the inode. There we have different blocks, direct blocks, single indirect block, double indirect block. We will see one by one. The direct block contains 0 to 11. It contains the direct pointer. Each pointer directs to the storage block containing file name, file data, which points directly to the actual data block that holds the file content. The first level pointer that allow the file system to quickly access the data. If the file is small, no indirect pointers are needed. The next one is single indirect block. That is, the 12th block is the single indirect block. It points to the indirect block. The indirect block contains the address of another address block, useful when file is large than the space covered by the direct pointers. Double indirect pointer. The 13th block is the double indirect pointer. It points to the address of the indirect block, and these indirect block points to the actual data block. When a file becomes even larger, the double indirect block is used. It expands capacity further. The next one is double indirect block. The 14th one is triple indirect block. It points to the block that contains address of double indirect block, then leads to indirect block, and finally to the data block. Used in the case of very large files, this multiple layer indirect system allows the file system to address massive files even when the file size exceeds the typical limitation of the direct and indirect addressing. The various applications of this inode is file management, direct structure navigation, access control and security, efficient disk usage, hard links and file sharing, crash recovery and file system check. Next is the advantage of inode: efficient metadata storage, fast file access, supports for large files independent of file names, flexible permissions and ownerships, efficiently linking. And the disadvantage is fixed number of inodes, extra data space for metadata, complexity with large files, inode table can become fragmented, hard links can cause confusion. Thank you.